This is FLN 12, which is volume with fractional lengths. And to start off with, we want to talk about three-dimensional objects. So here's a cube, and here's a smaller cube that is approximately a half the size of this cube. It's half the size of this front face and a half the size of this back face. Since it's all the same, cubes are identical, all the different sides. So we want to know how many of these half-size units fit into this full-size unit. So when I add these in, I can put this cube in, and you can look at it visually and approximate that I have about 8, right? 4 in the front, and then 4 in the back. So when you guys hear the word fractions, I know a lot of you kind of start to get nervous because you don't enjoy fractions. But just visually, I want you guys just to start thinking about this. This is a fraction. This is 1/2 of the unit here. And it takes 8 of these to fill up one whole. The next one says, well, what if I were to cut this up into a 1/4 unit segments. So this is approximately 1/4 of the length in the front. So if I put these in and I ask you how many of these, here I have to get the right ones, how many of these 1/4 unit cubes would fill up this entire three-dimensional object. And so you can start thinking about it with these die. I don't have enough die to keep going, but did you see there? I have 4 on the bottom, then there'll be another 4 here, and then a 4, and then a 4. And this, we will go through and fill the entire thing with die. And it comes up to, let me stop. Okay, so then again, here it is. I have 4 units across. 1, 2, 3, 4. 1, 2, 3, 4. So when I split this guy up into its units, I'm not doing a very good job here. I have 4 here, and then I'll have 4 coming across the bottom, and then 4 going up. So when I want to say how many of these 1/4 unit side lengths fit inside, I have 4 times 4 is the base, and that is
16.
16 times 4, which is the height. How many square blocks go up on the height side? So again, there are 4 that go up the side, and 4 times 6 is
24.
4 times 4 is 1 plus 2, 64. So there are 64 of these blocks, of these die, will fit inside this this three-dimensional object, or this cube. I don't have enough die to show you that, but you could visually start to see it. Okay, with this one, the question in this example is how many 1/3 centimeter cubes fit inside this rectangular prism. So the first thing I want to do is to split everything up into 1/3. So this 1 centimeter, I can split this up into 3/3, right? 1 centimeter equals 3/3 centimeters. Remember, anything divided by itself is 1, right? How many 3's are in 3? 1. 1 3's in 3. So I have a 1/3 here, a 2/3 here, and a 3/3 there, okay? And the same thing up the side. The height of this is 2/3, so I have a 1/3 here and a 2/3. So this whole distance here is going to be 2/3, and then up the side is going to be a little bit different. First, I have, this is improper fraction, or a proper fraction. I need to turn it into an improper fraction. So 3 times 2 is?
6.
Plus 2 is?
8.
So this is 8/3. This whole length here is 8/3. So then when I do this, I can split it up into 8 different thirds, right? So I have 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3, and 8/3 as I split this up into thirds. Now that I've split it up into thirds, I can start thinking about how many 1/3 cubes will be inside of this. It's obvious that I didn't do this correctly because these aren't, this is a shorter distance. I mean, I did it correctly, but the what is it called is off. The
Scale.
The scale is off, but it still holds, right? 2 2/3. So if I want to calculate how many of those of little 1/3 unit cubes fit inside this, I'll take the bottom, which is 3. 3 of these go across, and then 8 go across here, and then 2 go up here. So I have across the bottom, I have 3 cubes will fit. Across the back, going backwards along this way, I have 8 cubes will fit. And then going up the height, I have 2 cubes will fit. And 3 times 8 is?
26.
No. 8 times 3 is 24, right?
Oh, yeah.
Times 2 is?
48.
So 48 squares, 48 centimeter, 1/3 centimeter squares, 48 of these would fit inside this prism. So for this example that we just went over, let's say that we had to split this up into thirds. Let's pretend that this was a centimeter, and then each of these were 1/3 a centimeter. What they're asking is how many of these, when they're 1/3 of this length, will fit inside this cube. So again, you want to think about that you will take these and stack them across the bottom, stack them up on the side, and stack them up on this side. Okay? Okay, the last example has this rectangular prism, and it says how many cubes with the side length, just one side, of 1/2 a centimeter will fit inside of this, again, my perspective is slightly off, inside of this prism. Okay, so I know that if this is 1 centimeter, how many will fit in the front here if I have to split them in half? Because now this is the equivalent is when I take half of the front length, and that is now the size of this cube. So 1 centimeter gets split down the middle. This 2 centimeters along the side, so now each of these is 1/2 a centimeter, right? Or you could, like we were counting before, 1/2 plus 1/2 is 1 centimeter total. And then this side here, I have 2 centimeters. So when I split 2 centimeters, first I split it in half, and I have each 1 centimeter, and then I split it in half again. Okay, I'm gonna split this in half. So this is 2 centimeters, this length here. Centimeters, sorry guys. Now I have 1, 2, 3, 4, right? 4 1/2s fill up this centimeter, this 2 centimeters, okay? And there's 4 of them total. Now how about this side here? This is 3/2 a centimeter. So when I'm splitting up, let me move this over. When I'm splitting up 3/2 a centimeter, I have here, this is a 1/2 a centimeter, then I add another, and I have 2/2 of a centimeter, that's 1, right? And then this last one up here, I add another to it, and I get 3/2 a centimeter. So there are 3, that's what that fraction means, right? There are 3 halves in this distance here. So now I know that I've got this, 2 blocks can fit here, 4 blocks can fit here, and 3 blocks can fit there. And when I want then to calculate the volume, how many of these 1/2 units, 1/2 centimeter units fit, I'll take the base, which is 2, times this side, 4, times this side up here, which is 3. And 2 times 4 is?
8.
And 8 times 3 is?
24.
24. So 24 blocks that are a 1/2 centimeter in length will fit inside this pyramid. So when you guys are working on these on Khan, I know you guys probably don't have these at home, but I want you to start thinking about it this way. How many different ways, or not different ways, how would I fill up this 3-dimensional object with different fractional sizes of the length here? And that's what we're working on today.